Hey guys, Mr. Prusky here. Hope you're having a good day so far, and welcome to your last lesson of the year. Pretty awesome. Way to go. Thank you guys all for your commitment to learning these lessons this way. I know it's not ideal, and that I miss you guys. I wish we could do this in person more, but we still got to be safe. But I'm really grateful that you guys have, stuck with it and done a great job for me this year, despite not seeing you in person. And I don't know. Well, hopefully everyone gets their grades all sorted out here, turns everything in that they need to turn in, and I really hope that you guys have a great summer, and it's been really a pleasure working with all you guys, and I want to thank you for your hard work and your, just being funny and fun to work with, and, it's just been a great year, and I really want to thank you guys for that. So, all right, so Chapter 12, we're working with three-dimensional shapes still. Last lesson. Here we go. Our name of the lesson is, ready, 1, 2, 3, volume of prisms and cylinders. Essential question, ready, 1, 2, 3. How do I find volumes of prisms and cylinders? So, volume, surface area is like the outside of a three-dimensional shape. Volume is like the inside, how much it makes up the inside of something. All right, so we're talking about like cubic feet. That's like how many like square think of cubes of actual like feet of like actual cubes, that make up space. So like when you talk about square footage, I guess in a building or something, that's just like floor. But if you talk about cubic feet, that's more like the three-dimensional space that like makes up. Because you could have a square footage that's pretty small. Like you could have like a skyscraper has very small square footage. But it has a lot of volume because it's very tall. You know what I mean? So yeah, it's kind of a balance, but let's get right into this lesson. So, definitions. Let's start with green this day. Let's work backwards from what I usually do. Volume is the number of the number of what? Cubic units contained in its interior, in its what? All right. So, we have a few postulates here that are going to be the formula for volume of different shapes. So the volume of a cube, if you remember, the area of a square was side length squared. And so in a similar fashion, we have, so for example, this is a side length right here. We have this is a side length and this is a side length. So if we're multiplying all three of these together to get cubic space, that's going to be s to the third. And if you remember, area of a square, that was side length squared. So basically, we're multiplying. Let me actually write those s's a little bit somewhere else here. So we have side length, we have a side length, and we have a side length. So if we're finding the area of just the square in front, right? This is a prism. A cube is a prism. So that's going to be side length squared. And then the height of the cube is going to be this other side length. So it's going to be side length squared. Volume is going to equal side length squared times side again, which equals side length cubed. Okay? If you're still confused by that, just find the area. Like this would be the base. Any of these squares would be the base, and then multiply by the height, which is the distance between the two bases. These are two bases right here. Okay? All right, but it's just side length cubed. I guess we'll get into these right here. So volume addition postulate is very similar to the area addition postulate. The volume of a solid is the sum, The sum of the volumes of its non-overlapping parts. So basically that was like from 11.3 or 4, I think you guys worked on that, where you had like shapes that were like that. We found an area of that rectangle and this rectangle right here. Area those two things separately and then add them together. Same thing with volume. You can take a three-dimensional shape that's kind of wonky and not really a traditional shape that we know the area or volume for. You can find the volume of the different parts and add them up. And then the volume congruence postulate. If two polyhedra are congruent, then they have the same volume. Then they have the same volume. All right, so that makes sense, right? Two congruent polyhedra are going to have the same volume, because that'd be kind of weird if they were congruent and they also had different volumes. That'd be kind of weird. All right, volume of a prism is kind of similar to what we did before with the cube, but volume of a prism is actually, I think it's easier than surface area, which is kind of like 2 times the area of the base plus perimeter times height. This one is really super basic. I think it's a little bit easier. It's the area of the base times the height. So the reason why this is basically in this three-dimensional shape we have what we're doing is we're finding the area of this base, right? If we find we have a whole bunch of rectangles that make up this entire length right here, right? There's a rectangle here, there's a rectangle right after it, there's a rectangle further down, right? These are all rectangles that are inside of that three-dimensional shape, which is a prism, right? So basically what we're doing is we're finding the area of this base, and we're multiplying it by the height. Actually, they did it kind of goofy here, so let me fix this here. I don't want to confuse you. They did the base is actually down here, and this is the height. So basically, we have a whole bunch of rectangles that make up this, that make up that entire like height there, right? So we have a rectangle at the base. We have rectangles, actually infinite rectangles that make up each of this length right here, right? This height. So what we're doing, the way this works is we're finding the area of the base this height number of times, because that will basically fill in, that we'll have a whole bunch of slices. We'll have a whole bunch of slices that will make up this entire height of the shape. It'll have all those infinite rectangles are going to add up and be the, that's going to be the volume, basically. It's kind of a cool workaround. Instead of like finding some weird way to do this, it's basically you just find the area of the base and you do it a height number of times, and it'll fill in with infinite rectangles all the middle parts. Okay? All right, sounds good. Area of the base times the height. Cavalieri's principle. If two solids have the same height and same cross-sectional area at every level, then they have the same volume. The same what? So back here when I was drawing those little rectangles inside here, these were cross-sections like we talked about. Remember we drew like a slice through certain three-dimensional shapes, and we got like different shapes that came out there. So if you multiply the area of the base times the height, that will cover all the cross-sections. That was the word I was looking for. All the cross-sections that will add up to the entire volume. All right, and then volume of a cylinder is also a little bit easier than surface area, I think. It's going to be, again, it's area of the base times the height. But the area of the base, well, the base is a circle. And what's the area of a circle? What formula is that? Is it 2 pi r or pi r squared? Which one was that? It's actually going to be pi r squared. And if you are not sure which one is which, a shortcut is area is square feet. So this one's going to be, area is square feet. And so the squared one's going to be area. All right? I don't know if I mentioned that in previous videos, but... So all we're going to do, the area of the base is going to be pi r squared, and then we're going to multiply by the height of the cylinder. Okay? All right. And I think that's it for that page. So let's go ahead and find some volumes of prisms and cylinders. Okay, so let's use a different color now. Let's use blue. So we're finding the volume of this. Is this a cylinder or is this a prism? This is a prism, so we're going to do volume is going to equal the area of the base times the height. All right? Well, the area of the base, what's the base of this this prism here? Is it down here? Or is it on the sides? It's actually on the sides. Even base doesn't mean it's always on the bottom. Okay, base does not mean it's always on the bottom. Base is the two shapes that are parallel. You see how this triangle and this back triangle are parallel to each other in three-dimensional space? Those are the bases. And also, usually the bases are not the rectangles. If you have like triangles or pentagons or hexagons or something in there, your base is not going to be the rectangles. It's going to be the actual unique shapes. Okay. So the base is actually going to be a triangle. What's the formula for area of a triangle? It is base times height over 2. I'm going to move this over a little bit. Okay, so what is the base of that triangle there? It is 3. And what's the height of the triangle? It is 1. We're looking at this blue triangle right here. All over 2. So the area of the base is going to equal, what's 3 times 1? 3 times 1 is 3. 3 divided by 2 equals 1.5. So the area of the base of that triangle, of that prism, is 1.5. And what is the height? What is the height of this prism? The height is the distance between the bases, so it's going to be 2. So we're literally just going to plug into this formula. Volume is going to equal the area of the base, which is 1.5, times the height, which is 2. And we're going to get, volume is going to be equal to, double 1.5 is 3 cubic feet, because we're working with cubic feet in volume. Okay? So it's just area of the base times the height. Area of the base times the height. All right, letter B here. This is also area of the base times the height. But the base of a cylinder is a what? What shape is it? It's a circle, and the area of a circle is pi r squared. So we're going to do pi r squared times height. All right, what's our radius for this cylinder here? Radius is 5. It's this radius of the radius of the base, right? What is the height of the cylinder? That's going to be 6. So we're just going to plug into this formula here. So volume is going to equal pi times 5 squared times the height, which is 6. So volume is going to be approximately, multiplying by pi is going to make it a weird decimal. It's going to be, I think it's 471.24 cubic meters. And there we go. All right. Now, what is happening here? All right, so example 2. This one's going a little bit different than what we were doing, okay? It says the volume of the right cylinder shown is 1,253 cubic centimeters. Find the value of x. So this one we actually know, the volume of this. We're looking for the radius, which is x. The value of x is the radius. So we're going to use volume equals, we're still going to use pi r squared h. But this time we know the volume is 1253. We know the radius we don't know, we're looking for that. We'll call that x. And the height we know is 10. So this time we're going to plug into the formula, but we're actually going to solve for r, which is going to be x. So we have 1253, which equals pi times x squared. I'll just put x squared without parentheses. And then times the height, which is 10. Okay, hopefully that makes sense what we're doing there. Remember, sometimes we solve for different parts besides the actual volume. Okay, now, we're multiplying pi times x squared times 10. I want to get x squared alone. So how do I get rid of pi and 10? If this is all multiplied together here, how do I get rid of that? Instead of multiplying by pi and 10, we're going to divide by what? 10 pi. We're going to divide by 10 pi on both sides. This is going to cancel. This is going to cancel. When we divide by that, we're going to get 39.88 when you divide by 10 pi. Make sure you put this in parentheses when you're dividing on your calculator, else it might goof you up. Equals x squared. And now how do we undo a square to get x alone? We need to do a square root. So x is going to be approximately, once we do a square root, we're going to get approximately 6.32 centimeters. And it's going to be centimeters because it's just a distance. It's not a certain area. It's not a volume. Okay. Now, 1 second here. I'm going to pause the video real quick and do this. Okay. All right. Okay, we're going to do 2 more examples here. I'm probably going to walk you through the last example just briefly, but... Okay, so oblique and composite cylinders. Find the volume of the oblique cylinder. Okay, one thing you need to know about a oblique cylinder and a regular cylinder, the formula for volume is going to be the same. Okay? Just because it's slanted over doesn't mean it's going to change the formula for volume of a cylinder. That makes sense, right? Because there's a whole bunch of circles in here. They're just getting pushed over. They're not going to change like the actual volume. There's going to be, all these circles are going to be inside of here. And they're just slanted over, which means we're still going to have the same height and other stuff here. So we're still going to do volume equals base times height, which is for cylinder is actually pi r squared times height, because the area of a circle is pi r squared. So what's the radius of this cylinder here? Radius is 5. And what's the height of the cylinder? 8. So we're going to do volume equals pi times 5 squared times 8. So volume is going to be approximately, once we multiply that, 628.32 cubic inches. Okay? All right, and the last example is they call it a composite solid, which means it's, or composite cylinder, I guess. It is a cylinder with a hole in it. It's a cylinder with a hole in it. Okay? So we have this big cylinder here, right? And then we have the cylinder. This is like a hole in the shape of a cylinder inside of this cylinder, right? So the volume, how are we going to find the volume? Let's use a black here. So the volume is going to equal, if we're taking out a hole, what we're going to do is we're going to do the volume, let me see how I wrote it on here. The volume of the big cylinder minus the volume of the little, or small. Shoot. Okay? So we're going to do the volume of the big, which is this one right here. Okay, we're going to take the big cylinder, we're going to subtract the small cylinder here, okay? So the volume formula still is, for cylinders, pi r squared h. But the big cylinder, in orange, we're going to do pi, what's the radius of the big cylinder? The big cylinder is going to be 3 squared. And what's the height of the big cylinder? That's going to be 7. Minus, and in red, the small cylinder. What's the, we're doing pi, what's the radius of the small cylinder? It's going to be 1 squared. And then what's the height of the small cylinder? It is 7. So the volume is going to be approximately, we're going to get about, when we multiply that out, we should get about 197.92 minus 21.99. So the volume should be approximately equal to 175.93 cubic millimeters. Okay, this applies to any solid, though. We just did it for a cylinder. I just want to make sure I showed you one example. I don't know if we're going to quiz on this or not, or even like have this in the homework, but I just wanted to show you that you can take any solid, and like if you have a hole in it, or if you have an extra like overlapping part. So sometimes we have, like, let me show you what we have here. Sometimes we have a cylinder with a cone on top. That was a really bad drawing. Let's try to fix that. Nope. Okay, I just want to show you this real quick before we end the lesson here. Sometimes we have a cylinder with a cone on top, and what you would do for this is the volume is going to equal the volume of the cylinder plus the volume of the cone. Okay, we actually didn't learn about volume of cones and stuff too, but I just want to show you kind of what happens here. It's the same kind of principle. If you have something on top, or there's a hole missing or something, it's the same kind of principles. Okay? All right, thank you guys for watching. Last lesson of the year. You guys did amazing. So proud of you, and I'm really sad this is the end of our geometry journey. But I really hope that you guys, have some fun this summer while being safe, and that you live life a little bit, but also, I don't know, spend time with family. Probably spend a lot of time with family already, but I don't know what I'm saying. I guess what I'm saying is thank you for a great year, and I hope you guys have a good summer, and we will see you next year, unless you are a senior, which you probably are not. So have a great one, guys. Thanks.